Hey, welcome. Today, we are going to pull back the curtain on one of the most important, but kind of invisible technologies that powers the internet as you know it. We're talking about Kubernetes. Think of it as the conductor of a massive orchestra, keeping our whole digital world playing in perfect harmony. So let's dive in and see how it works.
You ever stop and wonder about that? You're in the middle of a binge watch, or you're streaming your favorite album, and it just works all the time. No hiccups, no downtime. Well, let me tell you, that is not an accident. It's the result of some incredible engineering that solves a really, really chaotic problem. And to really appreciate the genius of the solution, we first have to understand the chaos that came before it. Let's take a quick trip back in time to see how things used to be done. Okay, picture this. For every single update, an engineer had to do all of this manually. One server at a time, it was painfully slow, super tedious, and just begging for human error. A single typo, one misstep, and poof, you could take the whole app offline. And if you had hundreds of servers, it was an absolute nightmare.
And this was the moment of pure panic. When a server decided to give up, some poor engineer would get an alert, probably at 3 a.m., and have to scramble to log in and fix it by hand. Until they did, part of the application was just gone. There had to be a better way, right? Well, there was. And that's where Kubernetes comes in. It's the conductor we were talking about, taking this massive, messy orchestra of servers and making every part play together perfectly, and most importantly, automatically.
The best way to think about it is like this. It's basically an operating system for a whole data center. You don't tell Windows or Mac OS which specific core of the CPU to use for a program, right? You just tell it to run the program. Kubernetes does the exact same thing, but for a huge cluster of servers. It just handles all the messy details for you.
This right here, this is the whole philosophy. This is the big idea behind Kubernetes. It's what we call a declarative model. Instead of giving it a long list of step-by-step commands, you just declare what you want the end result to be. You say, hey, I want 3 copies of my app running at all times. And Kubernetes just makes it its mission in life to make sure that's always true. So how does it actually pull this off? How does it make this magic happen? Let's take a quick peek under the hood of a Kubernetes cluster to see the pieces that make it all tick. So a cluster is really broken down into 2 main parts. First, you've got the control plane. That's the brain. It's the mastermind calling all the shots. And then you have the worker nodes. That's the brawn. These are the actual computers that do all the heavy lifting and run your applications, basically following orders from the brain. Now, inside that brain, there are 4 key players you should know about. The API server is like the front door and the bouncer. All communication has to go through it. The scheduler is the ultimate matchmaker. Its job is to find the perfect server to run your app on. The controllers are the watchdogs, constantly checking to make sure that what's actually happening matches what you asked for. And finally, you've got etcd. That's the cluster's memory, its source of truth, reliably storing that desired state you declared. Okay, so that's the architecture, that's the theory. But what does this design actually let you do? This is where it gets really cool. Let's look at the actual superpowers this whole system gives you. The first one, and maybe the most incredible, is self-healing. Remember that server crash we talked about, that 3 a.m. emergency call? Yeah, with Kubernetes, that's not a thing anymore.
This is that declarative model in action, and it's beautiful. Let's say one of your apps, in Kubernetes speak, that's a pod, just crashes. Instantly, a controller sees it. It goes, wait a second, you said you wanted 3 pods, but I only see 2 running. It immediately tells the scheduler, which finds a new healthy home for a replacement pod. And just like that, everything is back to normal. All in seconds with 0 humans involved.
All right, next superpower, the ability to handle huge, sudden spikes in traffic without even breaking a sweat. We're talking about scaling. And the best part is how ridiculously simple it is. You don't have to log into a bunch of servers or start copying code around. You literally just change a single number in a text file. You say, you know what, I don't want 3 copies anymore, I want 10. Kubernetes sees that and its controllers immediately start spinning up 7 new copies of your app to handle the load. It's just that easy. And this all brings us to the bigger picture. This whole declarative approach that Kubernetes pioneered, it's not just a cool feature. It is fundamentally changing how we build and manage pretty much all software. So what are the big things to remember? Kubernetes automates all those tedious, error-prone tasks from the past. It lets us manage massive, complex systems by simply declaring what we want. And by giving us this automatic self-healing and scaling, it's really become the operating system for the entire cloud. So I want to leave you with this one thought. When you can stop treating your infrastructure like a bunch of individual machines you have to babysit, and instead treat it as one single programmable system that you can just describe in code, what new possibilities does that unlock? What amazing things can we build next?